and we are connected on YouTube.
Thank you all for attending this first collaborative event between the Journal of American Studies and the Lighthouse Bookshop. We're proud to be a part of this event, More Than a Glitch, Meredith Broussard, on confronting bias in tech. Meredith Broussard is the author of a new book, More Than a Glitch, Confronting Race, Gender, and Ability Bias in Tech, that was published in March of this year. She is also the author of Artificial Unintelligence: How Computers Misunderstand the World. She appears in the Emmy-nominated documentary Coded Bias and serves as the research director at the NYU Alliance for Public Interest Technology. Before we get started, I want to invite our viewers to write any questions you may have in the chat. And now it's my pleasure to present Meredith Broussard.
All right, Nicole, thank you so much for that lovely introduction. It is great to be here with all of you today. What I'm going to do is I am going to talk for about 20 minutes. I'm going to give you an introduction to the book, and then we're going to have plenty of time for Q&A. So let me get my screen share going. Oh, it looks like I don't have screen share, so I'm not going to do it with slides. All right, you're just going to get me. You're just going to get me talking about the book. So I want to start by telling you what is in the book. I start with a hype-free explanation of artificial intelligence. We all talk about AI nowadays, but when you really drill down, there are a lot of myths and misconceptions about artificial intelligence. And then talk about some examples of how AI discriminates or how technology discriminates. I give some examples from justice, medicine, education, and more. And then finally, because I realize that it is a bummer to just talk about discrimination, I offer some options for change. And those include narrative change, algorithmic auditing, algorithmic accountability, and a variety of responsible AI resources. Right. And so what I like to start with when I talk about artificial intelligence is I like to start with a definition. And so I would like you to think about the term artificial intelligence and think about what appears in your mind. And I'm going to guess it's probably the Terminator, right? It's probably the Terminator. It's probably stock art robot guy from, every stock art collection you've ever seen. Maybe it's a character from Ex Machina, from Star Wars, from Star Trek, from Her. Basically, Hollywood has a lock on our minds. And so when we think about AI, we tend to think about a Hollywood concept of AI. Now, it's really wonderful to think about Hollywood concepts of AI. Hollywood tells wonderful stories, but the reality of AI is that it's just math. It's just a computer, which is a machine that literally computes, right? It's doing very complicated, beautiful math. It's not magic. And in fact, we're all using AI all the time, and we've been using AI for years without realizing it. Every time you do a Google search, you're activating something like 250 different machine learning models. When you have a Zoom call and you get an automatic transcript of that Zoom call, you're using artificial intelligence. So we kind of expect AI to be Hollywood, to feel really special, but it's kind of mundane, right? So another way of thinking about real AI is that real AI is math. And in fact, it's just computational statistics on steroids, right? So let's talk about machine learning systems, which are kinds of AI that people talk a lot about nowadays. Machine learning is the most popular kind of artificial intelligence right now. There are other kinds. You've probably heard about expert systems, natural language generation, natural language processing, right? But machine learning is the most popular right now. And when we make a machine learning system, we do the same thing every single time. What we do is we take a whole bunch of data, usually data that is scraped from the internet, but just giant pools of data. Take that data, plunk it into the computer and say, computer, make a model. Computer makes a model. The model shows the mathematical patterns in the data. And then you can use that model for a variety of things. You can use that model to make decisions, to make predictions, to generate new text or images or audio, right? It's a very powerful model, but what it is it's a thing that recognizes the mathematical patterns in the training data and then reproduces those types of patterns, right? So it can only do things that it has seen before. And unfortunately, the model reproduces bias that's in the data. It reproduces the bias that's in the real world because there is no such thing as a perfect world, right? Every set of data that we're putting into AI is flawed in some kind of way, is biased in some kind of way, because we're all working to be better people every day, but we have not yet achieved a perfect world. So when people talk about the future of AI, they tend to talk about it as if it's inevitable. Like, oh, you need to lie back and let this, this very specific technological future happen to you. And that is absolutely not the case. We do not have to let a particular technological future happen. We can have agency in what our future looks like. And we don't need to focus on long-term future existential risks of artificial intelligence. It's very fun to talk about the robot apocalypse, but we do not need to obsess about it. There is no robot apocalypse coming. We should focus on present harms to real people. And there are a lot of those. Okay? One of the ways that I like to approach artificial intelligence is I like to use a frame that comes from Ruha Benjamin, scholar Ruha Benjamin, and her book Race After Technology. And this is the idea that AI systems or automated systems discriminate by default. Right? So out there's a kind of pro-technology bias that I call techno-chauvinism, an idea that technological solutions are superior to others. And if we back off of that a little bit, if we question that assumption, if we question that bias, it becomes easier to see how the problems of the past can be embedded in the data we use to train machine learning systems. So the problems of the past are structural. They're things like racism, sexism, ableism, and these are things that have happened in the past. They're reflected in the data we use to train AI systems, and the model gets to know those patterns and says, I'm going to reproduce them, right? So if we assume that these systems are going to discriminate by default, then it becomes easier to see what the problems are. So let me give you a couple of examples of ways that AI systems have been found to discriminate in the past. One example comes from the Markup, which is a really terrific algorithmic accountability news organization. If you're not reading the Markup regularly, highly recommend it. The Markup has a story called The Secret Bias Hidden in Mortgage Approval Algorithms. And they looked at these algorithms that automate mortgage approvals, that automate approvals for home loans in the US. And what they found was that these algorithms were 40 to 80% more likely to deny borrowers of color a mortgage as opposed to their white counterparts. And in some metro areas, this disparity was greater than 250%. Well, why is this? If you're an engineer or data scientist, you might look at it and say, oh, well, the computer is just making a mathematical judgment. It's fine. If you're a social scientist, you might look at this and say, oh yeah, I know exactly what's happening. In the United States, there's a very long history of financial discrimination against borrowers of color. There's a very long history of things like redlining, of people drawing a red line around particular neighborhoods and saying, all right, people of color can only live here. We have residential segregation in the United States. So all of these patterns are visible to the model in the data. And so it's reproducing these historical patterns of financial discrimination. Now, it absolutely is possible to put your thumb on the scale and even out the decisions made by something like a mortgage approval algorithm. We can set it so that it does approve more borrowers of color. Is anybody doing that? Not to the best of my knowledge. Another example of AI discriminating comes in the world of facial recognition. There is a project called Gender Shades, which looked at facial recognition systems and found that they're biased. Facial recognition systems are better at recognizing light skin than dark skin. They're better at recognizing men than women. They generally don't take into account trans and non-binary folks at all. And when you do an intersectional analysis, they're best of all at recognizing men with light skin. They're worst of all at recognizing women with dark skin. And so this is obviously a problem that these systems are biased. Part of the problem had to do with the training data that the companies were using to train the facial recognition systems. And in fact, when companies did have a better distribution of people of a range of skin tones in their training data, they did improve the accuracy of their facial recognition algorithms dramatically. But one of the interesting conclusions from this paper was that we can challenge uses of facial recognition, and we can look at particular contexts where AI is being used. And facial recognition used in the context of policing is actually a really bad idea when we drill it down into it, right? Because we know that it's biased. We know it is going to be biased against people with darker skin. It's going to misidentify them more often. So maybe the correct solution is not to use facial recognition in policing at all. You are probably familiar with one example of AI bias in hiring. There was a pretty well-known example of Amazon trying to use a machine learning model to look at resumes. And the way that they tried to do this was they took a model and trained it on lots of resumes, and they flagged the resumes of people who had succeeded at Amazon in the past and said, okay, find us more resumes in this data. Find us more resumes that look like the resumes of people who have succeeded at Amazon in the past. And you know what it did? Kicked out all of the women. Now, why did this happen? Well, we can look at the demographics of who has succeeded at Amazon in the past, and we can look at the demographics of Silicon Valley broadly. There are lots of groups individually who are doing a good job of addressing the gender balance problem in Silicon Valley, but broadly, Silicon Valley has a gender problem. And the reason that the model knocked out anybody who went to a women's college or played a women's sport is because it was operating on patterns that it saw that the human developers did not see about who had succeeded at Amazon in the past. So Amazon, to their credit, did stop using this, this experimental recruiting tool. But there are lots of other attempts to use AI or to use machine learning to sort through resumes, to do various things in the hiring space. And we need to be skeptical about all of them. We need to keep in mind the idea that automated systems, AI systems, discriminate by default. And we need to keep looking at these systems and auditing them for bias. And then the last project that I want to talk about is a project that is not in the book. It's relatively new. I wish it had come out earlier because then I would have put it in the book. But it is from Wired and Lighthouse Reports. And this is a project called Suspicion Machines. And the reporters in this instance looked at an algorithm that was used in the city of Rotterdam to try and detect welfare fraud. Now, algorithmic accountability reporters like myself, we get kind of our ears perk up when we hear trying to detect fraud in public services, because usually when people are trying to detect fraud in public services, what they're actually trying to do is they're trying to restrict access to public services. Right. So this particular project looked at the city of Rotterdam and an algorithm that they were trying to use to detect welfare fraud. And they found that this algorithm was biased based on ethnicity and gender. And so the reporters, for the very first time, were able to get their hands on the code, the data, the model, the documentation for this algorithm used in Rotterdam, and they evaluated it, and they found that the factor in the data that had the greatest weight in this machine learning model was Dutch language ability. Right, so people with very low Dutch language ability, especially women with low Dutch language ability, were being flagged by this model as being potential welfare cheats. Now, let's think about who has limited Dutch language ability and is applying for public benefits. It's recent immigrants, right? It's moms. So Rotterdam, to their great credit, did stop using this model. And that was one of the reasons the reporters were able to get their hands on it. All right, wait 1 second. All right, so this is a really terrific project, not just because of the reporting that they did, but also because the reporters who worked on this project published a 50-page methodology document about how they did their investigation. And to someone like me who loves looking at data, this is very exciting, but it's also really great in terms of transparency. You can go and you can look at what these reporters did. You can look at the code and the data and the analysis, and you can validate the results for yourself. And this is a way of increasing transparency. All right, apparently we have just been interrupted by a test of the National Wireless Emergency Alert System. That is pretty interesting. I'm glad it works. All right, so suspicion machines. Let's see. All right, so let me wrap it up. I've talked about a bunch of examples of discrimination, and I promised to talk about some happy stuff. So let me talk about solutions, because the final 2 chapters of the book are about solutions. One of the things that I think we can do to improve our overall situation is we can change the narrative around artificial intelligence. We can change the way that we talk about AI. So instead of talking about AI as inevitable, as magical, as Hollywood, as something that is going to be an existential threat to humankind, instead, what we can do is we can talk about AI as if it's a kind of mundane tool, a kind of mundane mathematical tool. It's basically like a really complicated calculator, right? This takes down the tenor of the conversation a lot and cuts through some of the hysteria. We can also invest more in a new-ish field called public interest technology. Public interest technology is just what it sounds like. It's about making technology in public interest. Sometimes that means doing algorithmic accountability reporting, like the folks at Wired, Lighthouse Reports, the markup, et cetera, are doing. In a world where algorithms are increasingly being used to make decisions on our behalf, the media's accountability function, right, because the media holds power to account, the media's accountability function has to transfer onto algorithms and their makers, right? So algorithmic accountability reporting is a kind of public interest technology. Another kind of public interest technology has to do with improving our existing technological systems. So one of the things we can do is we can audit our hiring systems, or we can improve our government systems. So for example, a public interest technologist in the US might work on strengthening a state unemployment website so that in the next pandemic, the state unemployment website doesn't go down when millions of people apply simultaneously for benefits. Sorry, I just lost my screen. All right. And then finally, let's talk about learning from journalists on the algorithmic accountability beat. I talked about the markup already. Also keep an eye on work coming out of ProPublica. ProPublica's investigation into the Compass algorithm is really what started the entire field of fairness, accountability, and transparency, which is the kind of intellectual underpinning of some of the investigations in the book. And then we can also think about what are the responsible AI resources that are coming out of the corporate world. There's been really great development of frameworks for responsible AI. NIST in the US, the National Institute of Standards and Technology, has a responsible AI risk management framework that is really helpful. There's some interesting stuff coming out of the World Economic Forum. Salesforce has done some interesting stuff. So you may have heard that some tech companies very famously fired their trust and ethics teams. This does not mean that ethics do not matter. It just means that some people made some problematic decisions at big corporations. And the conversation about responsible AI is alive and well and thriving. Then another way that you can read this book, More Than a Glitch, is you can also read it as a kind of set of pointers to fabulous things to read. So check out the bibliography in the back. I have lots of resources for learning more about the intersection of technology and race and gender and disability. Okay. So thank you very much. It's been a pleasure talking with you. And I think now we have time for some questions.
Excellent. By the way, Meredith, excellent. No slides needed. Riveting presentation. Now, Ahmed and I have a few questions that we'd like to ask you, and then we'll turn to our viewers, of course, who should feel free to post their questions in the chat box. But first, Ahmed.
Thank you so much, Nicole, and thank you so much, Meredith, for your fascinating talk. And I was really intrigued by your book going into it, especially since you speak to a lot of the fears and anxieties that people like me have in an increasingly tech-dominated world. The main focus of your book is, of course, to confront race, gender, and ability bias in technology. But I was wondering if you could also discuss socioeconomic biases as well. So certain tech products like the MacBook or the iPhone are priced in such a way as to deliberately privilege one type of consumer and therefore one type of social class over another. I was just wondering, how do these biases and barriers to entry affect the way that we engage with technology on a daily basis?
Oh, Ahmed, that's such a good question. The digital divide is alive and well, and it is still a problem. One of the things that that I read about explicitly in the book, but is also an underpinning, is the way that culture tends to fixate on the latest and greatest technology without going back and making sure that all of the previous technologies are well implemented, right? So we see this in the digital divide, right? We still do not have wireless coverage or cellular coverage everywhere in the world, right? So there are places in the US, there are places that are within 3 hours of New York City, where I live, that are rural and do not have cell or high-speed internet, right? So we need to make sure that all of our infrastructure is up to date and that people have what they need in order to access the latest technologies. We saw this a lot during the pandemic. It turned out that there were lots and lots of kids who did not have computers at home to be able to participate in Zoom school. There were kids who were going to library parking lots and like crouching in parking lots or sitting in a parent's car in a parking lot of the library because that was the only place they could get a Wi-Fi signal because they didn't have internet at home, right? We see a lot of disparities. And so saying, oh yeah, AI is going to take over the world is going to leave out a whole bunch of people. There are also disparities that happen in pricing mechanisms. So people who have a lot of money often don't think about the cost of poverty, right? It's very expensive to not have money. You end up getting charged more for things. And in fact, this also happens sometimes when it comes to pricing. So you're probably familiar with the fact that there's dynamic pricing on some websites. A few years ago, I think it was the Wall Street Journal did an investigation about what are the prices for different goods on different platforms. And the assumption at the store had been that people who are using mobile devices have more money, right? Because, you know, iPhones are so much more expensive than, say, Android. So they would present a slightly higher price to a user who was accessing the site via a mobile device, and they would present a lower price to the person on the desktop. Well, it turns out that a lot of people of lower income don't have desktop devices, are only doing their computing through a phone or through a mobile device, right? So it was a hidden cost, right? So we need to just stop with our assumptions about, we need to stop assuming that everybody has the same type of access to technology, and we should stop assuming that technology is the answer to everything.
I see, and that's a brilliant lead into to my next question about the idea that sort of technology can solve everything and it can save the world, because I was struck by your discussion in the introduction to your book of the concept of techno-chauvinism, especially the idea, and I'm quoting from the book, algorithms can't sufficiently monitor or detect hate speech, can't replace social workers and public assistance programs, can't predict crime, can't determine which job applicants are more suited than others, can't do effective facial recognition, can't grade essays or replace teachers. And yet techno-chauvinists keep selling us snake oil and pretending that technology is the solution to every social problem. And to me, that sounds like a profoundly dystopian idea, or the potential for a profoundly dystopian future that recurs throughout science fiction, including 2001: A Space Odyssey and The Terminator, which you cite at the beginning of chapter 2, and which you also mentioned in your talk as kind of epitomizing these fears and also epitomizing our ideas of what we perceive technology to be. And so how close do you think we are to reaching a kind of a dystopian relationship with technology? Or have we already reached that stage? I'm not necessarily meaning a robot apocalypse by any means, but certainly tech systems which make our lives more difficult and fraught than they already are and that they have to be.
Well, I think a lot about what it was like during the pandemic, because when things shut down during the pandemic, in many ways, that was the sleek technological future that many techno-chauvinists imagine, right? So we were the people who could afford to stay home stayed home, while the people who couldn't afford to, like the essential workers, were forced out of their homes. And if you were a person at home, then you could just order everything to come to the house, and you didn't have a social life, and you just talked to people through the computer, and you ordered things through the computer, and you didn't interact with that many people, and it was horrible, right? And that actually is the future that that a lot of techno-chauvinists have been striving for, right? This kind of seamless future where you never have to leave the house and everything comes to you, and stuff is automated and algorithms mediate your social interactions. And it's great to be able to order stuff on your phone. It's great to be able to get delivery, but it's also great to be able to have social interaction. It's great for people to have jobs, and of course nobody wants another pandemic. So I think that we should, instead of having a kind of universal ideal of, oh yeah, this is the tech-enabled future that is one particular vision and we need to strive for that, I think we need to have multiple visions of the future, and we need to just accept that the world is never going to be fully machine governed, right? And that it's fine if we have a world that is partly about machines and partly about humans, because it's really all about the humans, right? It doesn't make any sense to make the world convenient for machines, right? Like the self-driving car people have this idea that, oh yeah, we're going to get all the humans off the roads, and it's just going to be self-driving cars on all the roads. I mean, that's ridiculous.
Fantastic. Yeah, and if the pandemic is any indication, what the techno-chauvinists want is essentially a future that is characterized by profound loneliness and social disconnection, and just sort of you staring at a computer screen 24/7, and that's no way to live.
Yeah, exactly. And really stark economic inequality as well. It requires a ruling class and a servant class, and that's not, we've moved on from that.
Well, recently I met a bot designer in London who showed me how she could have various types of conversations, ranging from the saucy lady with a sense of banter to the serious English teacher through these bots. However, she admitted that this form of AI still didn't comprehend reality. And I didn't understand what she meant by that comment. In chapter 5 of your book, Real Students, Imaginary Grades, you write, and I quote, "The computer doesn't feel shame at the way the United States has failed the 10.5% of its citizens living at or below the poverty line. It simply predicts that the rich kids will earn higher grades than the poor kids, and then it waits patiently to fulfill its next command." Now, is this passage an example of AI's inability to perceive reality? Are we being increasingly pulled into the fantasy world of the finely tuned algorithm?
Well, to me, I think that it starts with understanding what's happening when somebody is talking to a bot, because it is really nifty to talk to a bot. It is really nifty to use one of these generative AI systems. I recommend that everybody tries them. You're going to have a lot of fun for like 10 minutes, and then you're going to get really bored, right? Because it's really only 10 minutes worth of entertainment, because it is, I don't know, the best way of describing it is that AI responses are profoundly mid. Right. So what the AI is doing, what the model is doing, is it's taking in lots of text, let's say, that's scraped from the internet, and is building a model that shows the mathematical patterns that it observes. And then it's spitting out a sequence of characters. And a space is actually a character to a computer. So it's just spitting out a sequence of things, of characters interrupted by spaces, and it's throwing in a period every so often. And you and I perceive that as a sentence, but the computer just thinks it's a string of characters, and it's making the string of characters based on character patterns that it's seen in the past, right? So we've actually had bots that can respond since the 1960s. There is a bot called Eliza that was based on modes of Rogerian therapy. And so the bot, you'd say, oh, I'm feeling down today. And I would say, you're feeling down. Tell me more about that. Right. So you can do these kind of scripted responses. And then when you're looking at thousands and thousands and thousands of people's interactions and requests to a bot, you can start to see the patterns in them, and you can script the pattern that the bot should respond with, right? You can guide it. So that's how these systems work. It's not magic. And so when you come into it with the mindset of, oh, it's so mysterious and so magical, then that's how you experience it. When you come into it with a mindset of, oh yeah, it's just kind of a mechanical process and the computer is not understanding anything, and it's just, you like interacting with a machine and it's kind of sad, like, yeah, you're going to have a different experience of it. So if we stop imagining that computers are magic, then we're going to transform our relationship to them.
Thank you for that. It's reassuring. Well, in chapter 7, you carefully walk us through the unholy alliance between hegemonic cisnormativity and math, on which our computer's binary system is built. You also expose all of the administrative growing pains data process or data systems are still going through and processing information on the transgender population. How long do you think it will take to create and normalize gender fluid algorithms, or is that even possible?
Well, it's going to take a lot of money and a lot of time. I can point to what NYU, my employer, has done to make its computational systems more inclusive. So in that chapter, I write about the gender binary and how it's enforced inside computational systems, right? So, the idea of the gender binary, well, computers work on binary numbers as well. Right? You've got a logic gate, and you've got a 0 or 1 based on whether the logic gate is open or closed, and that then gets transformed into all the cool stuff that we do on computers, right? And so the way that gender has traditionally been recorded in computational systems is binary, because people used to only record gender as, either male or female, 2 values. And you used to have to be really stingy about the space you used when you built a computer program, because space or memory used to be really expensive. Like, we only had limited processing power. So the thing you had to do was refactor your code down to run in as small a package as possible. And also, we still try and make code run really fast, right? Because people don't want to be waiting around for a computer to respond. Well, one of the ways you can make your programs run faster is you can use as little space as possible for your variables. So gender tended to get stored as a binary. So if you want to store gender as a string of text characters, not just a 0 or a 1, that is a totally straightforward fix in a computer system. But the world we live in is not just about a single computer system, it's about networked computer systems. And especially at a place like a university, you have a kind of core set of systems. It's usually called the student information system. And then you've got hundreds and hundreds of other systems that feed off of that core system. Right. And the student information systems were generally set up in the 1960s. Right. This is when in the 60s and 70s is when universities started computerizing things. Right. And like they're very messy, they're very sprawling. It takes a lot of effort to go in and rewrite your student information system. You know, people just tend to not do it. You tend to just add things onto it without, you know, redoing the underlying data structures. So if you were to go in and change the representation of gender from a binary to a string, it's absolutely possible to do it. But then you're breaking all of the systems that rely on the student information system, because the other systems are expecting to get a binary and then they're getting a string and they're like, what? I don't understand. And then, you know, so it's not impossible. It's not a major technical challenge, but it is extremely expensive and time consuming. And you know, a university has to really want to do it. They have to invest in changing their systems. And I'm so pleased that NYU has done this. I know there are other universities that have done this, but not everybody has. There's also a really interesting thing about Facebook. So Facebook very, you know, is very public about the fact that, oh, you can be you know, one of like 50 different gender, you know, gender representations on Facebook. You have 50 different options for your gender on Facebook. But then when you look in the back end, how it is represented and how it's sold to advertisers is a user is sold to an advertiser as male, female, or null. Right. So it's literally nullifying gender identities that are beyond the binary.
Okay, that's interesting. In your concluding remarks, you state, and I quote, "Tech is racist and sexist and ableist because the world is so. Computers just reflect the existing reality and suggest that things will stay the same. They predict the status quo," unquote. But what are some simple changes that we can make in our lives that can contribute to moving the needle on the status quo? For example, if we can make changes in our lives to reduce our carbon footprint, is there anything we can do, we, the intelligent consumer of hardware, software, IT services, and social media? What can we do to call out or reduce bias in tech?
Well, we can call for audits of our technology systems. If you are in the position to purchase enterprise software, right? So if you are making a contract on behalf of your employer for a software system, you can ask for evidence that the company is auditing its systems for bias, right? You can make that a requirement before you sign the contract. And you can be a more conscious consumer of technology, right? You can think about the environmental footprint of technology. You can think about how many mined minerals it takes to make new computationally enabled things. And no, maybe we don't need to embed, you know, smart wireless in everything. We can also agitate for policy changes, right? So I am particularly enthusiastic about something in the US called the Blueprint for an AI Bill of Rights. And it is a framework that uses human rights law as its starting point. I think this is a fantastic starting point. I think this is absolutely the way to go. And the big idea is that you have the same human rights inside computational systems that you do in the real world, right? And one of the rights that you would have is the right to contest a decision. When a computer makes a decision that goes against you, you would have the right to contest it. You would have the right to talk to an actual human being who believes you and is empowered to change the computer's decision, right? So when a mortgage decision goes against you, you would have a right to an explanation of why this decision happened. If the decision is wrong, then you'd have the right to have it reversed or addressed, right? Now, this goes against how many businesses are trying to use AI. They're trying to use AI to reduce headcount, to not have customer service. And I mean, I think we're all pretty frustrated with that at this point. We have reduced headcount as much as possible. Everybody hates AI-based computers or customer service. It's incredibly aggravating to not be able to talk to a human being. It's incredibly aggravating to talk to a human being who is on the other side of the world, who answers the phone. Customer service is just a mess.
Thank you for that. So now I'd like to open up the Q&A session to our viewers. And I'm going to have a little peek on the chat here to address some of your questions. Ahmed, do you want to address the first question I see here? Or comments? Ahmed, I think there's one. Well, I'll let you have a look at the first.
I've lost all the questions. I'm really sorry.
Okay, well, let me see. From what I can see, there's a lot of comments. So I'm going to go down to the first question that I can see is a question. Let's see. I'm going to look at the one here at 732 from Allison. Looks like this is a question. Or I'm going to go up a little bit further. I think I can see one here from Jones. Right, so I think this will do. So Jones says, I love methodology sharing. Is there global, and I'm thinking especially of non-Western input or better accountability systems? Is that?
Yeah, there is an evolving community that is thinking about algorithms and accountability. I would point you to work by Deborah Raji, R-A-J-I, about algorithmic accountability. Also, Denai Metaxa at University of Pennsylvania. Deb Raji is at Berkeley, University of California at Berkeley. And so I will not get into the mathematics of it, but basically you can look at algorithms and you can evaluate them for specific kinds of bias. There are lots of different kinds of bias in the world. If you go on Wikipedia, you can read the list of cognitive biases. Well, there are also mathematical dimensions of bias. We can look at, is an algorithm privileging certain groups over others, and then we can decide how much of that is permissible, because you do have to decide how much is permissible, and that's another whole can of worms, because I think there's no there's no agreement on that, right? So it's an opportunity to have a different kind of fight. But at any rate, use mathematical methods for auditing algorithms. There's also a Slack community that Deb Raji runs that's about algorithms, auditing, and accountability.
Okay, my apologies to Lola, who asked the first question. It is both chilling and unsurprising that the facial recognition bias endures, especially as surveillance grows. I am interested in how you, as a data scientist, check your own biases. Do you have accountability feedback loops to catch blind spots? It was refreshing to see disability covered in the scope of your book, for instance.
Yeah, that's a really great question. And I am, I am human. I'm no more perfect than anybody else. I have unconscious bias. You have unconscious, we all have unconscious bias, and we're all trying to become better humans every day. We're all working on it. But we embed our unconscious biases in the technologies that we create, and that we can't see it because it's unconscious bias, right? So one of the ways that we can work against this is we can have more diverse teams of people creating our technologies, and we can empower people on our teams to speak up and kind of raise a red flag when a system is likely to be biased or affect certain groups differently. When I was writing the book is about race, gender, and disability, and disability was the thing that I had to learn the most about. I thought that I was okay on understanding race and gender, but I very quickly realized that I had a lot to learn about disability, and I am really grateful to the folks who shared their experiences with me, to the scholars who helped me understand the issues in the field. And one of the most powerful concepts that I came across was the idea that there's no one size fits all approach to disability. What we need to do is we need to listen to people, and we need to give them the technologies and the accommodations and the design that they need for their specific circumstances, right? And I also think a lot about a way that we design technology. So when we design a computer program, we design for the largest group of people that we can think of, right? And every programmer starts with thinking about their own experience. And they're like, okay, well, how do I design for the greatest number of people who are most like me? And people with disabilities often get pushed into those edge cases that computer programmers don't think about. And you can only write computer programs for this kind of articulated mass of people. Like, you have to kind of push everything else into an edge case, and you have to say, all right, well, we'll just deal with that later, and then it doesn't get dealt with. Or you say, all right, we're going to let human beings deal with the edge cases, but then those edge cases do not get prioritized. And if people with disabilities are getting pushed, are always considered edge cases, like that's terrible design. And that is exclusion, not inclusion. So we need to design for disability, because when you do design for disability, everybody benefits.
Okay, our next question is from Noor. Are algorithms like the facial recognition being implemented by default, or do public bodies need to show some kind of safeguarding and checking outcomes?
This is changing. I'm glad you asked this. So in the EU, you are seeing the most comprehensive AI legislation in the world that is going to effect right now. It's the EU AI Act. And one of the interesting things that this act offers is a division into high risk and low risk uses of AI. So it's really hard to legislate AI in the abstract, right? You can't write rules for all AI everywhere throughout time. I mean, you can write mathematical rules for it, but in terms of writing laws and policy, it's very difficult. So what you need to do is you need to tie the kind of AI to a context, right? So it's very hard to write rules for facial recognition overall. But what we can do is we can tie facial recognition to a particular context. We can say, all right, we're going to write a rule about facial recognition in policing. We're going to write a rule about facial recognition on phones, all right? So we're tying AI use to a context. And then we're also looking at high risk and low risk uses of AI. So facial recognition used to unlock your phone is probably a low risk application. It doesn't work for me half the time. It's not really a big deal. I just like do my passcode and I call it a day, right? So facial recognition to unlock the phone, probably low risk. And under this legislation, low risk uses of AI would not need to be regulated / monitored, but high risk uses of AI would need to be registered, regulated, monitored. So high risk use of facial recognition might be facial recognition used by police on real-time video surveillance feeds, because people with darker skin are going to be misidentified more often by the facial recognition. Folks with darker skin are going to get caught up in the legal system more often. As a result, it's going to have really dramatic, disparate impact. And in fact, there's a lot of reasons to be cautious about using more advanced technologies in policing, because the history of them is just so atrocious. So I read a lot in the book about a kind of software called predictive policing software. It's a kind of software that tries to predict where crime is going to happen. And so there is a new study that came out today from the markup looking at PredPol, which is a predictive policing software, and it was found to be largely ineffective.
I'm going to skip down to Melanie Lee, just to make a comment to piggyback on that. She says, so it's not surprising that facial recognition can't readily recognize dark people or women if the system was tested mainly or only upon white men. Is that why my own smartphone can't always recognize me?
Okay, so there's a couple things going on there. One is that it's just not very robust technology. Like, it just doesn't work that well. There's also the problem of, being better at recognizing light skin than dark skin. And then there's also a deeper problem, right? So let's go back in history to the development of the technology that preceded facial recognition and computer vision. And that technology is color film, right? So all of these things are cumulative. All of the technological advances build on previous technological advances, and anything that wasn't solved earlier, like the problems, tend to get wrapped in to the future iterations, right? So color film did not represent a range of skin tones well, right? So when Kodak invented color film in the, whenever they invented color film, they would send these things called Shirley cards to individual labs so that the labs could tune their machines to particular colors. And they were called Shirley cards because the name of the woman on the first card was Shirley. And the Shirley card would show a picture of a white woman with light skin and a couple of like primary colored balloons or pillows or something, right? So they would send out these Shirley cards every year for tuning the machines, and the Shirley cards did not have a range of skin tones on them. And so brown skin tones would come out looking muddy. And Kodak did not fix this because in, the 1970s and 1980s, like, African-American actors started becoming more prominent. They did not fix it because they suddenly had a change of heart around understanding that their systems needed to be inclusive. No, it was because furniture manufacturers complained, right? Furniture manufacturers complained that their walnut and mahogany furniture looked muddy, and they were not going to switch over from black and white catalog printing to color catalog printing unless Kodak fixed its browns, right? So they did that. However, this idea of treating people with darker skin as edge cases has persisted. We see it in video game technology. There were video games that you could wave your hands around and it would control stuff in video games. And guess what? It didn't recognize people with darker skin, especially in low light conditions. We have the racist soap dispenser. You've probably seen the viral video of the soap dispenser that doesn't work for a man with darker skin, and then it works for the man with lighter skin, right? So again, we're back to discrimination by default. We need to assume that these systems are going to discriminate, and we need to not turn over decision-making to these deeply, deeply flawed systems.
Well, my apologies for those of you who were not able to have your questions answered, but I suggest, if I may plug this excellent text, that you look to the bottom of your screens or on the Lighthouse Bookshop site to engage further with Meredith's work. It's just fascinating, and maybe perhaps you can find some of the answers to your questions there. I'd like to thank Meredith for taking time to engage with us and to share her work and thoughts. And I welcome you all to continue your journey with Meredith through her work. And I'd like to thank you all for coming. Have a nice evening, everyone.
Thank you so